Hello and welcome back to recitation. In this problem, I'd like you to compute the area of a triangle. This triangle sits in space and it has its three vertices labeled here as P1, P2, and P3. So we're going to compute this area and we're going to do it using the cross product, which we learned about in lecture. So why don't you take some time to work this out, pause the video, and we'll check back in a minute and see how I did it. Hello and welcome back. So the first thing that I like to do with a problem like this is I like to draw a picture so I can kind of think about what's going on. So we have this triangle. We have this triangle sitting out in space, and we know that we want to take a cross product in order to compute its area. But we need to be careful. Cross product doesn't make sense to take cross product of points. What makes sense is to take cross product of vectors. So the first thing that we need to do is build some vectors that describe this triangle. And the vectors that we need to build are P1, P2, and P1, P3. Since we're going to use these in a minute, let's go ahead and compute them now. So P1, P2 is just the difference of P2 minus P1. So we get 0 minus a negative 1, so we get 1, 2, and 1. And let me just check my notes to make sure I did that right. Good. And P1, P3, we get, again, 0 minus a negative 1, so 1. We get minus 1, and then we get 1. Let me again check my notes. Very good. OK, so now that we have these vectors, we need to remember that if we take the absolute value of P1, P2 cross product with P1, P3, this will be equal to the area of the parallelogram they enclose. So let's get started by computing this cross product. So P1, P2 cross P2, P3. So remember, to compute a cross product, we take the determinant of a matrix where we put in our unit normal vectors, I, J, and K. And then we enter in the remaining entries of the matrix are just the entries of our vectors. So we do 1, 2, 1, and 1, minus 1, 1. OK? And so we can compute this, and we get, so the I component, we get 2 minus a negative 1, so we get 3. Now the J component, if we look at the cofactor matrix, it's just 1, 1, 1, 1, and that has determinant 0. So our middle component is just 0. And finally, the K component, we get minus 1 minus another 2, so altogether we get minus 3. So what that tells us now is that that this quantity here, the magnitude of the cross product is just 3 times the square root of 2, just looking at the length of this vector here. So we're almost done, but let's go back and look at what we had to start with. We were interested in the triangle over here, which was enclosed by the vectors P1, P2, and the vectors P1, P3. And what we just computed is actually the area of this parallelogram, which, as you can see, is twice the area of the triangle that we're actually interested in. So going back over here, we see that the area of our triangle is equal to 3 root 2, and we just need to divide by 2 to get the triangle. OK, and I'll leave it at that.